Alright, so guys, first thing you have to do, you have to just identify where you have. So me look at them. Like for example, I would observe and say this look like an isosceles triangle. That's the first thing I would observe because this is a radius and this is a radius. That means these two lengths are equal. That means these two angles are also equal. Isosceles base angles equal. So that's our first thing. I would notice and say this is the center of the circle and angles at a point add up to what? How many degrees can you go right round? That's the clue. Right? One circle measures 360 degrees, so it will be 360. We need to find that one. So it will be 360 minus 220. That will give us this value right here, and then we can use angles in a triangle. So that will leave
140.
Yeah. So this is 140. But we know that angles in a triangle sum up to what? So it will become easy now. All three angles should give you 180, right? So all we have to do is just subtract this to find out where them two angles are worth. Some people stop at 40. When I get the 40, guys, this is not for x alone. It have to share even with the two of them. Because a 2x is 2x equal 40. Because x, right? So these two angles are equal and the two of them add up to 40. That means it would be divided by 2 to get the value of one of the angle which they asked for. So therefore x is equal to 20. So what I want you guys to complete number 2 and then we can discuss it just like this. Alright? But you have to identify this is an isosceles. So these are equal because they come from a radii. So if this was 7, this is also 7. Angle drawn from center to circumference. That make it a radius. Alright. So look at number 2 now, guys, and then we can discuss also. Alright, so let's write down the size of angle ABC. So they wanted to find this angle. Whenever you see it like this, it's the angle in the middle. The talking. It's like they want to find angle B. So this, it will be this angle right here. It's rather simple than we think, you know. This is the center, right? So we can say that angle at the center is twice the angle at the circumference. See it? Look at the shape here. The focus on this alone, then you would see. You never need the 64 at all. So angle at the center is twice the angle. So all we have to do is just divide it by 2, which will give us 58 degrees. Also, we could have did the long way form. Alright, let's do it the long way. I'll maximize it and show you guys. So you couldn't see that same time, right? You can identify that you have an isosceles triangle, which is this one here, AOC, right? That's an isosceles. That means this and this equal. These two are equal. So if this is 116, we can find the value of these two. So that would be 180 minus 160. For 1 from this episode, right? So boom, we get 4. 1 from that leaves 6. So this becomes 64. So these two angles add up to 64 and we divide it by 2. So that means right here is 32 and here is 32. Now this angle right here is equal to this angle right here. So if we find this, we could know what this is. Now these are between a tangent, it's a tangent, a blue line here, and a radii. So that means that all the way around here, so add up to what? Anybody can tell me? Angle between radii and tangent.
90 degrees.
90. So if we say 90 minus 32, that will give you the 58, right? And this angle right here is equal to this one right here. So there's more than one way that we could have looked at. Alright. For number 3 now, it's a little bit more, I don't think it's really complex, but you have to be thinking about a lot of things. Like, for example, this would be like a quadrilateral, right? The angle here is on the inside part. But if you notice, this is the angle at the circumference. So that means we can find this angle right here using the rule that angle at the center is twice the angle at the circumference. So this angle right here will be 56 times 2, which gives us 112. So if here says 112, we can actually find this angle around here, because angle at a point add up to what? 360. I think once we find this, then we know that these 3 should add up to, these 4 should add up to 360 degrees. So we can subtract the 112 from the 2 from that. I can't knock over 1. So that left 5, boom, this leaves 8, 4, 1 from that leaves 2. So these are 248, right? And we know that the 4 angles should give you 360. The angle here, I don't know why they put the x so far. The angle here, this one and this one should add up to 360. That is a quadrilateral, right? So we can just say, all right, add up these 3, 248 plus the 32 plus 56. Let's find the total for this, which is 8 and 2, 10, and that's 16. So 6 carry 1. And this now, 5 and 3, 8, 12, 13. So that gives us a total of 336, right? But remember, it's supposed to be 360, so we just subtract 336 from that. 6 from that you can't, so we borrow 1 from the 5. That leaves 4 now, and then 3 from 5 leaves 2. So this is actually 24 degrees. That's how we can reason to. Alright? So guys, I could go down to number 4. Just finish it. I could go down to number 4 and then. Alright. So 4 is a calculate angle CBA and angle CBA. So want this angle right here. I also want this angle right. So I think we could find CBA first or easier, because if you look closely at this portion here, CBA would be the angle at the circumference, while the 140 will be the angle at the center. So all we have to do, just follow the rule, divide by 2, right? Because angle at the center is twice the angle at the circumference, or the angle at the circumference is half, so we just divide it, and that will be 70. So this angle works out to 70 degrees. And if you look close, you can see that it's a cyclic quadrilateral, because the 4 vertex or vertices is sitting on the circumference. That one look like it's shaky, you know, that one there. But we know say basically, yeah, it's supposed to be sitting exactly on it. We don't know what happened with it. Right? Probably won't see it if we never zoom up. So that means this angle plus this angle must equal to 180 degrees. So if we know that is 70, all we have to do, just subtract 70 from this, which gives us 110. So this works out to 110 degrees. So these are 70, and these are 110. it'll be about either 3 or 4 marks, you know, guys. All right, so this was the last one to find the angle size of TQR. So you can see that is the outside here they actually want you to find. All right, how would we approach this? More than one way. We can look and we see that this is a radius, this is a tangent. That means right here would be 90 degrees. That's the first thing that kind of stand out to me. That means we can find this because angles in a triangle add up to 180 degrees. So 90 plus the 34, or we can just simply subtract this from 90 because if this is 90 already, that means this angle plus this angle must give you 90. So 34 from that will give you 56. So this right here are 56. It's vertically opposite to this. So this that means this is also 56. Okay, if we want to, we also find these two. Because these two are vertically opposite and it's an angle at a point, right? So all of it add up to 360. If we feel, I'm going to find it. So if these are 56 and 56, that's 112, right? So if we find that one, that'll be 360 because the whole angle add up 360 and this equals this vertically opposite. So this will be 112. That'll be 8. This left 4. So the two angle add up to 248. So we can divide it by 2 to get this angle here. 2 into that 1, 2 into that 2, 2 into that 4. So it means that this are 124. Right? So what that does now, we can find this. I see it will come from the radius. So that means this is an isosceles. So we could find this angle right here. So it would them add up to 56. That means when you divide it by 2, this are 28. And we can find this by saying, all right, this one is a tangent and this one is a radii. That means all of this add up to 90. So it would be 90 take away 28. Was it supposed to be 28? Yeah, 28 and 28, 56. So let's see if I can just point that here. Alright, so 90. Oh, 62 we get for this. This angle is supposed to yeah man, 62. These two supposed to add up to 90. If we want, we could also find these angles, you know. The angle here supposed to equal to this. Two of them are come from a radii, right? So that means we have another isosceles triangle. So 28. So 56 from that hour. 124, right? This is one. Even though we found it already, you know, but let me just check so 56. 180 take away 56. That's 124. So this are actually 62. Because them two here add up to 124. So these are 62. And these are 62. And remember, this angle here is equal to this. But you just want to find it because I know some persons might go the root there. and find this. That means that this is equal to this. Remember, all the angles in the triangle must add up to 180. So you could do a double check, guys. Check this angle right here, 28, 90 plus the 28, and 34, and see if it give you 180. So you could double check. I want you guys get in the habit of double check your work. So 28 and 28, 56, right? This and this, 56 plus this, 90 plus the 90, 180. All of the triangles must add up to 180. 62 plus 62 and 56, that's a 90. 34 plus 56 plus the 90, that's a something. And you can check that big one here too. 62 plus the 12 plus the 28 plus the 28, that should give you 180. All the triangles must add up to 180. So you can do a little double check. So guys, we're gonna end for today. See you guys on Wednesday, alright?